Hey guys, in this video we're going to be looking at database transactions using Entity Framework Core. Now, I have here the .NET 5 console app and we had written all of these wonderful functions up until this point. However, I'm not going to create a function, I'm just going to write some code underneath here. But before I do that, let us assess some of what we have gone through already. We've looked at saving changes to our database, whether it was through adding or it was through updating, whatever it was, we have looked at how we can save the changes or even deleting. So the fact is that a transaction, when it comes to database terminology, really refers to having everything as a unit of work, which means that everything gets done or nothing gets done. This would come in handy when you have maybe a complex operation that has changes that need to be made to multiple tables, and what you don't want is orphan the data, right? So if you have to add a record here and then you have to update a record and then delete another record, if one of those operations fails, then you would end up with some half data, half done operation against your data, which is very dangerous. So by default, our save changes operation actually builds in that transactional method, right? So when we are trying to, and you know what I'm going to do, I'm going to try and uncomment some of these things so we can look at how these methods worked, right? So when we talk about adding the new league, right, we looked at how we add new league here, and we looked at how we add the new team. So let me uncomment these so we can look at both of them. So what happens is that we would put the data together, of course, and then we would state that this is the change we want to make, and then we would save changes. So obviously what this would do is commit those changes to the database. If we had multiple things doing, for instance, if I didn't do the save changes at this point, right, and I said league, I want to add that to the leagues table, and then I went ahead and did this operation, these two operations would stay in stasis until I call this save changes. So the save changes at this point would actually be in charge of looking at all of the changes that need to be done now and carrying them out. If one of them fails, then the save changes would have failed and nothing gets done. So for that reason, Entity Framework has the built-in transactional methodology in it, right? It does everything as an all or nothing operation. So you're probably wondering, okay, so if it does it already and we know how save changes work, then why are we having this conversation? Well, the next thing that you should take note of sometimes is that there are times when you need to save the change first so that you can get the ID to create the next record, right? So let me give you an example of that. We have here the operation to add teams with league, right? And we're saying the league ID would be whatever league is. So that is why we had to say save changes for the league. So we could add the league, and then we could pass in that league so we could get its ID, and then we save changes again. Now, if this save changes failed, that means we would have a league record with no teams added to said league record, right? Now, there are times that cannot happen. It's all or nothing. So we can't afford to have the league without having the teams. If they are supposed to be a package operation, then we need them to be a package operation, even though I actually need to save one of them to the database before I can do the other one. So for that reason now, Entity Framework gives us the concept of actual transactions where we can allow the save changes here, which does like a temporary commit to the database. And then we save changes here again, which does another temporary commit. And then we have to commit the transaction, which would finalize everything. And if that finalization does not work, then it will roll back the save changes as well as this one. So let's take a look at how that would work in this exact example. So what we would have to do to get started with that is define a transaction variable at the top of the operation. So I'll start off this method and I'll say var transaction, is going to be equal to context dot, I always get the spelling of context incorrect, context dot database dot begin transaction. Right? That's our first step. Then at the end of all of this, or at the end of all of the operations, whatever it is, you're updating, you're deleting, you're massaging, whatever it is you're doing, you have to do transaction.commit. So what this will do now is state that even though I have saved changes in between, I am going to make sure that they get committed successfully as a complete unit. And then one pattern that you would see here is that you'd put the commit in the try catch, right? So you do all of the stuff outside, right? And then you try to commit. And if you fail to commit, then you catch your exception and then you can, log it wherever it is in your app. So console dot right line, and then you state your error would be whatever it is. So at that point, if the commit fails, nothing here would get done. Right? So that is the power of a transaction. This is where you can actually save the changes in between, but nothing gets finalized until you actually commit. And bear in mind that you have to start the transaction like you see here in that example. Now, the next thing to this would be that there are times when you may want a part of the operation to be successful, right? And then another part might fail, right? Let's say, for instance, if it's a case where, yes, I would love everything to happen as a unit, but if the commit fails, then I would want at minimum the league object to exist. All right, so I'm just giving you patterns. I'm not saying you must write your code like this, because your context should always determine what you do, and make sure that your requirements, your requirements would dictate or have it that this needs to be compensated for. But the fact is that with the transaction, we can have what we call a save point. So if I wanted to say at minimum, if the commit fails, I would like to roll back to a certain point of the transaction, I can take a snapshot of what has happened at this point, right? So I can say transaction dot create save point, right? And I'll just do the async. So await create transaction dot create, and then I have to give it a name, right? So I have to say name saved league. Right? So at this save point, I have saved the league. As far as I know, this happened successfully, right? And of course, you could also put all of this in the try catch. You wouldn't put the declaration in the try catch. So you could put all of this in the try catch, right? Because then if all of this was successful and then we create the save point and then maybe it failed here, right? Or it failed here, then I would want to roll back to that snapshot and tell the database, well, roll back to the last snapshot and let us keep that representation of the data at that point. So what I could do inside of the catch is say transaction dot rollback, and then I could give it that rollback point. So the cool thing about the transaction is that you can roll back all the changes that were made, and then in this particular situation, I can choose to roll back to that particular save point, and that's why I have this error, because this is saying rollback. So this says discard all changes made to the database, right? So let us backtrack a bit. So if I did not have a save point and all of these changes happened, I could explicitly state rollback. By default, it would do a rollback. So this would kind of force a rollback, and there might be another situation where if maybe the value that you were expecting was incorrect, then you'd want to roll back. Well, this is how you would do it manually or enforce it. By default, however, if the commit fails, it does an automatic rollback. Now, if I want to use the save point, then what I would do is roll back to save point. Here we go. Let me just use the async there. So await roll back to save point, and then it's taking the parameter, the string name of the save point, which would be here. So if I had multiple save points, right, I can determine, okay, what is the minimum save point that I would want to go back to if I catch an exception. All right. So I'm not entirely sure what I would do at this point to kind of mess up this database. I would probably have to drop one of the tables or change the name of a table or something like that for the save changes to actually fail. So you can run that test, right? So you can change the name of the physical database of the leagues table, right? Of the teams table, sorry, so that the league gets created, and then when it tries to do the context save changes against the teams, it would say it cannot find the teams table, and then you would see that the transaction commit fails, and then it catches that exception, and nothing would have happened. Versus trying it again with the rollback, right? So what I'm going to do is split these methods out. I'm going to revert to the original, and then I'll show you with the regular transaction and commit, and one with the rollback and save point example. All right, so my refactoring is complete. Let me just walk you through it. So I reverted the add new league to its original form, like what we did in the initial stages. So no changes there. However, I created two new methods. One, add new league transaction, where I create the transaction and then we try all of that operation to try and commit it, and then we catch the exception afterwards. And then I have another one where we say add new league transaction with rollback, where we begin the transaction, we do one operation, set the save point, try the other one, and then we roll back to save point. So you have the both code examples as to how your transaction and potential rollback operation could look. So just to close this out, a transaction helps us to keep our operations atomic, meaning all or nothing, right? Everything is seen as one operation. And if the one operation fails, then everything inside of that operation fails. So by default, save changes does a transaction. However, it would usually do it up until when we have multiple things and we do need to save changes in between, but we would like to roll back those changes if one of the operations fails or one of the saved changes fails, then we have to enlist the use of the transaction, which is tied to the particular context. So if we have two contexts, each one can have its own transactional object. However, when we start the transaction, everything done before the commit is not finalized until we call the commit. And then thirdly, we can actually create save points or checkpoints where if we need to roll back to a particular point in time or to at minimum a particular operations completion, then we can choose to roll back to save point, and then we target the save point section.